Welcome. Because of a track meet on Monday, I have to record this video so you learn a little bit about the parts of a wave. I'm going to put it out this Saturday as I'm recording, and you can watch it this weekend so you're ready to do the assignment, or watch it in class with your headphones and finish that assignment. And we will recover it. We will be talking about both the Epicenter Lab and this when I get back on Tuesday. So let's hit it. So in previous lectures, or a previous lecture, I did talk about these, but we're going to hit them a little bit more in depth today. So we're really going to look at a transverse wave. And so if you think about a transverse wave, that's the one that goes up and down. That's the one that we think about a lot when we think about waves. So number one, remember that we have the crest, and this is the highest point. The trough is the lowest point, and the amplitude. This is the distance from the top of the wave down to what we call the resting position. And that's that middle line. And I'm going to show a picture of that in a little bit. Or you can also measure it from the bottom to the resting line. And remember that resting line is right in the middle. And number four, wavelength. This is the measure between two equal distances. Like I said before, most of the time we use crest to crest. Sometimes people use trough to trough, whatever the easiest to do. So these are four important definitions. Make sure that you get them down, obviously beyond tests and quizzes. And at any time, if I'm going too fast, of course, pause the video. Now we're going to get into a little bit of the math. How do we measure these waves so we can tell them apart from other things? So first one is is called period, and that's T. That is how long it takes for a wave to do a certain point. So we can pick a point, see how many waves pass it in a certain amount of time. Now, knowing that, we can find the frequency, which is really, we're going to use the word vibrations. How many vibrations does this do at a given time? And our equation for frequency, as you can see there, is 1 over T. Now the key there is that 1 really is the number of waves. And T is the seconds in there. So you can see that V, it says measured in hertz, 1 wave divided by seconds. And this determines, you music people, like the pitch of your sounds. And here's a special point that I think we forget: inverse relationship. So as frequency increases, the period of the wave will drop. And then we have speed, which we know what speed is. It's meters per second, but we're really going to talk about waves. And so you can see that we have frequency, which we've talked about before, in hertz, and then lambda, upside down Y, as I call it, and that's in meters. Again, when we do math problems, we have to remember our units. Okay, so let's look at a couple of these pictures of waves. Now on this picture here, this is not a transverse wave, but a longitudinal wave. And so I'm going to circle a couple points in here. And compression part of the wave makes sense. It's compressed together. Now the one that we talk about being spread out is rarefaction. So if you take a second thinking about our vocab, it is almost on the bottom. That's an important one. So make sure you get that down. That's in a longitudinal wave is where it's mostly spread out. Now, if we're looking for a wavelength in this one, we would find two identical points. In this one, we find 2 points right where it's compressed the most on both sides, and that would be our wavelength. So there's an example of a longitudinal and the compression and refraction of them. Now, here are the more traditional waves we do. And if we take a look and study these a little bit, we're going to see a couple different things. So let me move this up. Normally, very basic one. Again, we have our crests there on the top as I circle them, and the troughs on the bottom. Now, those are just definitions, got to remember them. And I think the crest is the easy one. The trough might be the harder one to remember. Wavelength, from one point to the next, normally we use the crest, but you can use the wavelength. Now here is where we talked about the amplitude, the power. I show amplitude from the midline down on this one, but again, that same distance is from the midline up. So you can also calculate the amplitude there. As I'm talking about amplitude, you can see way down in the bottom right here that amplitude of a wave is related to its energy. So how big it is up and down, more energy. So I try to show that here and there, that where one on the right is high energy and low energy. Now, I try to do my best here that shows the wavelength of both of them also being the same. Now, looking at the bottom left, we can talk a little bit about frequency. And this is just how fast this wave is moving or how squished in they are. You can see the top one has high frequency wave and the bottom one is a low frequency wave. So there are some characteristics and different things of these waves as we go. All right, at this point, I'm gonna go through these questions nice and slow. I want you to write them down. I wanna be able to go over them, but make sure that you have them. So the multiple choice ones, I'm gonna have you do, hopefully look at your notes and do them. And then I'm gonna do some of the math questions that we have. So I'm gonna do this, pause the video, answer the question, move on. All right, question number one. And these ones are just definition questions. Question number two. Question number three. And question number four. As we do these, remember that these are good test questions. So these are how I'm going to test you on these definitions. What type of wave is this? Longitudinal or transverse? What's the difference between those? If you need to, scroll back in the video and look at the two types. Question number 6. Question number 7. Question number 8. Hint on this one, this is frequency. Question number 9. My hint in this one is I would write out the equation for this one. So we're talking about wavelength and speed. So I'm going to use V equals frequency times lambda. That's that upside down Y. Now maybe you have to go remember what those things are. And what is the SI unit for frequency? When are the particles are the farthest apart? This was the one that I circled. We talked about the one that I think it's a new word for you. And now let's do some math. So this question, as we read, it says, what is the velocity of a wave with a frequency of 6.0 hertz and a wavelength of 0.0020 kilometers? Well, when I read this, my first idea here is to circle or square what it's asking for. And it wants velocity. So I'm going to write the velocity equation down. And that's velocity equals frequency times lambda. And I call it the fancy upside down Y. So we're solving for V. F is frequency. We know it's frequency because it says it, but the key point here is that it says it's in hertz. So we can write that down, 6.0. Now, do we have the wavelength or lambda? We do, but we have to remember what wavelength is in. In this case, wavelength is in meters, and they give it to us in kilometers. So we have to change that. You don't have to show this. You just have to make sure you put it down correctly. And this would be moving the decimal place 1, 2, 3 to the right. So this case, what is our speed or velocity of this wavelength? Well, 6 times 2 will equal 12. So our wavelength, our velocity is 12, and we can't just do 12. What's speed or velocity? Meters per second. So there's a pretty basic question, but again, we always have to work on our units. Mr. Foss used flashcards when he was studying these. All right, let's look at another question. What is the speed of a wave that has 17.5 waves per second and wavelength of 45 centimeters? Well, again, when I read this, I'm hearing the word speed. Now, we use speed and velocity interchangeable. In this case, we know that velocity really has a distance, but our equation is still the same. Velocity equals frequency over lambda. Now, I'm going to break this apart a little bit because do we have frequency? Well, frequency equation is 1 over time, or waves divided by time. In this one, we have 17.5 waves per 1 second. So that's really our frequency. Just kind of gave it to us in a different wording. So we do have frequency. And again, that's just by our definition, waves per second. Now, wavelength, they do it to us again. They give it to us, but they give it to us in centimeters. And so we're going to have to move that. And just to remind us what I use King Henry died by drinking chocolate milk. I want to get to my base unit, and I'm in centimeters, so I'm going to move it 1, 2 to the left. So if I'm going to meters, this would be 1, 2. So now this is actually 0.45. So I'll do the calculations here really quick. 17.5 times 0.45, and I get a speed or velocity of 7. We'll use 2 sig fig or 3 sig figs in this one. Maybe I should just use 2 actually. Let's do it right. Do 2 sig figs. Because 45 is 2, so that'd be 7.9. And what am I missing? You got it, my label, meters per second. All right, I'd like to hit at least one more question here, and let's read through this. A wave has a speed of 2.1 meters per second and a distance of 3.6 meters between wave crests. What is the period of the wave motion? Well, this one becomes a little bit more difficult. I'm thinking, hey, what equation has period in it? We have to remember period is a time. So that actually is frequency equals 1 over our period or time. So we got to get to that. But what does it give us? That's why I make this one's a little bit more difficult. It gives us speed and distance. So we got to use our speed equation. Velocity equals frequency times wavelength, and solve for frequency then time. So we can plug in our numbers now. 2.1 is our velocity, will equal frequency times our wavelength, and they were nice this time, gave it to us in the correct one. So to do our math here, I'm going to divide both sides by 3.6, and I get F, or frequency, to be 0.58. Now, again, that's not the answer. We want the period of that. So now we can put that 0.58 in for F. So if I do that, I have 0.58 equals 1 over time. I need to get time by itself. So if I multiply both sides by t, I'll change this color. So if you're kind of watching here, you can see that there's a little bit of a difference here, or step, times both sides by t. And then I'll have to divide both sides by 0.58. So at the end of the day, how do we need to solve this? Well, t will equal 1 divided by 0.58. So t equals 1. We'll round to 2, 7, and this is in seconds. All right. There's 3 main types of questions. Now, what I would like you to work on the rest of the time is pages 3 through 5. The first page is really, hey, what's a crest, what's a trough, amplitude, stuff like that. And then the next 2 pages are really on the math. If you get stuck and can't finish it, don't get worried. Come with questions on Tuesday, because Tuesday, again, we got a lot to cover because Mr. Foster's been gone for 2 days for track. So once again, I appreciate you guys working really hard on this while I'm gone. Let me know what questions you have.